Good day, grade 12 learners. We continue with how to calculate the normal force. We are going to look at example 3. Still, we are looking at a force that is applied on an object at an angle. But this time, that force is a pulling force. In the previous example, in example 2, it was a force that was applied by pushing on the object. This time we're looking at a force that is pulling the object along a horizontal plane as shown in diagram 1. Our main aim here is to calculate the normal force. For us to determine the normal force, we need to draw all the forces acting on the box as shown in diagram 2. The 100 Newton applied force is being applied at a 30 degrees angle, and it has got therefore components, the vertical component which is Fy and a horizontal component which is Fx, and then the other forces acting on the box include the Fg, which is the gravitation force, and then we also have the normal force which is acting up, and finally the vertical component of the applied force which is Fy. We are going to use diagram 3 to calculate the normal force. Remember, forces that are acting up added together, all of them are going to equal to forces that are acting in the downward direction. Having that in mind, we can see that from diagram 3, if you consider forces going up, we have Fy plus N, which is equal to Fg, the force going down. And then if you rearrange that equation, you get N equals Fg minus Fy, where Fy from our right angle triangle in the middle in diagram 2, Fy is equal to F sine theta. And therefore that gives us, after substitution of Fy equals F sine theta and Fg equals mg, we get N equals mg minus F sine 30. And then you substitute the rest of the values, you get your normal force to be equal to 97 newtons. Notice that mg is equal to 15 times 9,8, which is 147 newtons. If you compare those two, they don't have the same value. Mg equals 147 newtons, while the normal force is 97 newtons. Therefore, we can conclude that the normal force N is not equal to mg. And in this particular case, our normal force is smaller or less than the weight of the box, the weight of the object, mg. Let's proceed by looking at the last example, which is example 4, an object resting on an incline with a force applied F going upward. If you draw all the forces acting on the box, you have the diagram that is shown. You have got force applied going up, and then you have Fg perpendicular plus Fg parallel and the normal force. But remember, for the normal force, we consider only forces that are acting in the vertical direction, and therefore, if you look at the forces acting in the vertical direction, we have only the normal force versus Fg perpendicular. So the normal force must equal to Fg perpendicular. But from that right angled triangle, FG perpendicular is equal to FG cos theta. And we know FG is actually mg, so the normal force finally becomes mg cos theta. That is always going to be the case for an object on an incline. The normal force is equal to mg cos theta. Thank you for watching this video and for listening. Until we meet in the next lesson. Thank you and bye-bye.